Okay, we are now recording the session. That means the video file should become available at the end of the session in the website that you already know where you can access it. Um, the recordings for cloud architecture will be stored in a slightly different location, as you probably already understand that scenario. Is the idea that you want to store it in the architecture section. So we have that recordings now shifted over to the architecture segment. And then inside cloud architecture, you can scroll to get to the point where you will see fall 2018 recordings. And that section has only one, which is the maybe two. Huh. Already. I didn't remember that. So two recordings from October 31st and November 2nd. So let's check the calendar quickly, which is here. And what we are looking at is the calendar view. And so we have how many more sessions going. Let's go check that. So we have today is what day is it? November 5. So this is November, that is 5. That is the cloud architecture segment today that we are dealing with. And then we have that 1, 2, 3, 4, 5, and 6. 6 sessions left in the bootcamp. So it finishes on this date. You already know that. So just letting you know that we have 6 more sessions to go. And in that session, I want to make sure that I optimize our use of time and focus our attention on things of your interest, as opposed to things that I have in mind, because I have more content that I can actually cover in the bootcamp than we can fit in the remaining days that we have with us. And so we have discussed the last time that I would like you to watch a bunch of, at least a couple of videos. They were these guys, like the introduction to cloud services architecture video, which you may have watched already. So I'm going to skip it and go forward with the next idea, which is the idea that I actually want to talk about myself, and I will describe this idea to you. And then next one is, which I am assuming that you have seen it already, understanding application requirements. And what I would like to do is go back a step and look at a bunch of slides that I have there apparently here. Here are some slides that I want to actually refer to. These are the only slides that I have apparently that I actually am referring to right now, mostly for the purpose of a discussion that I want to have, or rather just to recap my memory of what this thing is. So okay, I got that in my memory now. So let me now switch over to, as you know, I dislike PowerPoint. I have the slide just to refresh my memory, and I am done. So I will go back to not using the slide again, back to cloud architecture. And what I'm going to talk about today is that entire slide deck that I just briefly skimmed through. And in there, what I would like to do is open up a new sheet of paper, and in there, talk about what I have in mind in that slide deck. And so the core idea behind any kind of architecture, in any kind of thing that you want to do, you're basically serving a customer, and that customer typically needs some applications, and you want to create them and give it to the customer, and then they pay you money. Either this money is internal money in form of you receiving a salary, or sometimes it is actually cash that your company receives. So that's the common scenario. You have a customer to service, and you provide that customer a service, and you give them applications, services, whatever they ask for, and they return the favor in terms of typically mostly money. So that's the business deal. Now, when we are looking at designing an architecture for a given solution for a problem that the customer may have, we want to solve that problem, and that problem typically is needs to be understood, and then we have to construct a solution that addresses that need. And I think those things are obvious. But what I'm pointing out right now in this discussion is that there is this division between people on that side and people on this side. This is your company. And on the other side, it's the customer. So that is the real division of, or I should say, boundary, which you need to understand and define. That you provide your value here, and you capture value in the other side. Now, when I draw this division or the boundary in a slightly different form, and I will do that right now, is you have the company in here. For example, here is the company that I have that actually is going to be, let's say, the company that makes sugar. And the company sells sugar to customers. So you buy sugar, I buy sugar, lots of people buy sugar, and they consume sugar. Now the question I have for you is, apart from these sugar manufacturers that you may have, just imagine that you know of a company that makes sugar. That I don't remember any names of those companies, but let's say if you can find a company that makes sugar manufacturer. Let's put some names here so that we clearly understand what are we talking about. So here is the company called Sugar Industry. Let's see, the biggest sugar makers are here, this name. Let's choose the name British Sugar, just a name, right? British Sugar. That's the name of the company that makes sugar. And it may not be available in US, but just understand that that's a company that makes sugar. And you buy, I buy sugar. So we are customers. We pay them money and we get sugar. Now imagine a case where there is a person that works for the British Sugar Company. Here, that person in that company. That person can also be a customer of theirs. They can buy sugar from the company itself. Similarly, the sugar that this company makes needs to come from somewhere. It needs to be coming from some kind of a plantation. And so that plantation is your, for example, you go to Hawaii, where you will find lots of sugar plantations. And so that's where sugar cane comes from. And so the input that I'm talking about here is cane, or rather sugar cane. And the sugar cane company will make payments to the plantation and get cane, and they will process to make sugar and then give sugar to the customer. That's the idea. Now, help me understand cases in which this sugar that you have here from British Sugar Company becomes a little bit more interesting to this customer, provided there is something here, like some magical thing here, X, that will make the sugar a little bit more interesting. What would that be? Do you know? What would that be? That this customer, that person who buys sugar, will also like to buy something else from this X company that will make sugar very interesting. What is it? Or what could be it? Like, give me some examples. There are many examples where the item sugar itself by itself is not that interesting, actually, if you think about it. There are very few people I know that eat sugar directly, like just by itself. They typically get something else to go with sugar. Like, you know what I'm talking about, right? Do you? It's common sense. There is no rocket science here. Like simple
Like coffee or
coffee. Yes. Coffee,
tea.
tea, right? Those things. You just add sugar, and then suddenly the sugar becomes very interesting. That's right. And that's the plus sign here, right? So that it becomes interesting. This nature of the plus sign basically is a coefficient. It's a positive coefficient, like makes it interesting, like in a positive. Now similarly, there are these other things here that are, say, y, that makes this sugar less interesting. This is positive, and so more interesting, more interesting. There are some things out there that make sugar less interesting. What is that thing? It is not rocket science, just simple common sense. So more interesting, less interesting. That's the idea I'm looking to find. More interesting. What would that be? And if you have sugar and you have that also, then sugar is not as interesting. It may be, but not really. Not as interesting. Slightly less interesting. What would that be?
Maybe sweet and low.
Yeah, exactly. Sweet and
I mean,
low,
I find that less.
right? Those things. Yeah, sweet and low, Splenda, those things, right? Alternatives. These are alternatives to sugar. And so the idea behind this less and this more is a very, very simple economic idea I'm talking about right now. Let's go see what that economic idea is. So what I just discussed is that we have this maker of something like sugar, and we have these guys called X and these guys called Y, and they are alternatives. In economics terms, they will be called substitutes because they effectively substitute sugar. And here is the idea of tea or coffee and like that. So these things are, they have a word for it, like substitute is the economics word for Y. There is for X, there is a word for it in economics. That word is complement. And remember, the spelling is like this. It is not the one that you know probably. It is this spelling. Complement. Yeah. This is the letter E as opposed to I. So you look good is a compliment. But I'm talking about this complement. That is the nature of these items. So why did I discuss these things? Because these ideas really positively impact the experience of you using sugar. And you got tea. And here is your Splenda or sweet and low. And that's negatively impacting your use of sugar. And so these are your customers. The plantation are your suppliers. So they have a name for it, supplier. There is a complement, there is a substitute. And the reason I am discussing these things with you is that there is a scenario where these things apply all the time. Like everything we do in business, in economy, in any kind of transaction where money is involved, these things apply. The same ideas come into play. Let's go now take a look at an example of a company that you know very well. And let's go put that company right here. The Boeing company. Now, what does Boeing make? Planes. So what goes here and what goes here? These are your substitutes. These are your complements. And these are your suppliers. And here are your customers. So the question I have for you is, who is here? Imagine the situation when a Boeing plane 787, it becomes less interesting to be customers with a negative sign the moment you see this item. What is that thing? You know what that thing is called?
Bad news story.
Huh? Right?
That's a bad news story.
No, it's
Gosh.
an item, not a news item. It's an item that somebody sells, like Splenda.
Mm,
You're saying like Airbus, like a
Yes,
competitor?
Airbus.
competitor. Okay.
Yeah, Airbus. So yeah, here. Who are these guys? What is it that suddenly becomes very interesting to a customer about Boeing the moment they find this thing? What is it?
Like a desire to travel?
That is there, but that is actually desire to travel is these customers, like you and me, right? And you want to travel, I want to travel, so you buy tickets from the airlines. Airlines, they are the customers, right? So airlines will buy, let's say I want to travel to Hawaii, and so I go to Alaska Airlines. Alaska Air is a customer, and so you have a desire, you and me and people like us have a desire to travel, and so you buy ticket, and these guys sell you tickets, and then they let you travel, and you pay them money. That's the desire comes from right here. But what is this? The way to think about it is this item, the moment this item becomes available, that it becomes suddenly very interesting, that this Boeing plane becomes very interesting to Alaska Airlines. What is that item?
So like the design or the mock-up or
That you provide. So this is like somebody else. This design markup is all you give them. You give them a entire plane. You give them everything that is needed to run and operate a plane. Everything you know what you do. You know better than I do. And so the idea here is that if you have Alaska Air and they want to buy a plane, they want to give these guys money, right? Ton of money. And so that money is something that is, if you have to buy like 20 planes, it's a lot of money. And so you want to help these guys out. And so what is that here that becomes interesting so that they can actually pay you money so that they can buy it from you? What is that thing? And I'll give you another example to help you pick that idea. The idea would be, remove this. Put here Qatar Airlines or Emirates. Now those guys have a ton of money. Like, they carry like $1 billion cash in pocket. So they don't need this thing. They don't need this thing.
so will that be like the bank or the
Yes.
financer?
Yeah.
Okay.
That's exactly. So these, companies that give you loans or easy money or lending agencies like GE Capital, for example. GE Capital will help you with a loan. And so as soon as you have access to a loan, then you suddenly find that this plane becomes interesting because you can actually afford to buy one. Without that loan, yeah, it's good, but I cannot really buy a loan. That's the situation which, most airlines are like that. Not everybody is an oil-rich country, in those Middle Eastern airlines. They are very rich. And so basically gas is free for them. So they just, you know what Middle East is. So I'm not talking about that. But that's the idea. So if you now redraw the whole idea again one more time, here is the company. Here are the people that I call complement. There is another word for them. Is actually that's the right word. I would keep that word, complement. Complementor. Let's call it that. Here in these guys, there's a word for it. I call them substitutes, but the proper word to use is competitors. And then here are your customers. Now, in case of the Boeing company, where do you fit in, like individuals, Emily and Corey and people like you? Where do you fit in this picture? So I have this person, Emily and Corey. Where would I put them? These guys in the pictures. There are these bubbles that I'm drawing, right?
In the Boeing company circle.
You mean here?
Yes.
Okay. That's the natural reaction that most people will have. That's the answer most people will provide. And let me tell you that that is not the case. Because here is the Boeing company, which is the company itself, not its employees. Its employees are actually suppliers. They supply their skill, their time, their dedication, right? Their effort, dedication, their effort, their everything they do, every single day, all day long, whatever it takes, they just do everything. But that is not the company itself. You provide these things, time, dedication, effort, skill, everything, and you get paid salary. And that is the transaction. The nature of transaction is that you give and you receive. And that the nature of this transaction, where you're giving them skill, time, dedication, effort, and everything else, makes you a supplier. There is no other way to say it, but just understand that that's the only way in the given frame of reference, the way I'm drawing it, you are a supplier because you give your time, your energy, your effort, your dedication, and everything. And in return, you get a salary. The moment you receive money, that makes you different from them because that company is the entity that employs you, so that they are different from you. Just realize that from an economic standpoint, that's the relationship. So I hope you agree with me. So unless you own the Boeing company itself, which is a different case, in which case I am wrong. You have to be owners of the company, by the way. If that's the case, I will put you right here. If that's the case, wow, but I don't know. So you tell me. But I think you understand the point. The point is clear that you belong in a case where you're transacting, you are giving them skill, and you're getting salary. That makes you a supplier. But the reason I bring up all these things is the fundamental idea that I really want to point out to you is that you work for a company, like you currently do for work for this company. And there are these people who are complements. And then there are these suppliers. And so that's how the whole economy operates every single case. Wherever there is a transaction, there are some things that will make it interesting, some things that will make it less interesting. And this is the product or service that you provide, and here is the money you collect. And that goes in form of a network. This network that I'm talking about is basically a chain. So like this, and like that, and like that. It doesn't stop. There is always a chain of things that are happening that eventually build up to something like, this customer. Again, there are more and there are more. It's a complete chain of value where you give value and you receive money. That's the transaction. That's how the economy operates. This idea is defined by Adam Brandenburger and let me just type it. It's hard to write for me. I'll just search it. It's easier. So Adam Brandenburger. This is a good book I'm actually referring you to, by the way. This book is called Coopetition. That's the name of the book. And it's written by Adam Brandenburger and Barry Nailbuff. These are two professors from Yale and Harvard, and it is a textbook. It's a textbook that I think you should read. even though it has nothing to do with cloud computing. The reason I'm suggesting that you read is because it gives you real clear idea about what is business and how to operate in real life. In case of a transaction happening, like you an employee working for an employer or maybe a customer, things of that nature. You will understand it much more clear provided you read the book. And in that book, you will see the idea of value net. And so, where is that idea? Value net should be in this somewhere. You will find in the article. I hope to find it. If not, I will have to search another way. But that's the same picture I just drew. That I actually took it from the book. That idea of let's go search it. Value net. And there is a Wikipedia article also on the same idea right there. And that's the value net idea right there. You see? Except that I have the complementers and the comparators kind of left and right flipped. But that's not an issue. The issue is, come on, advertising, stop. Yeah. The issue is that this is the core building block of transactions in economy. So that's the concept. You need to always think of these things in mind. Now, before I go further in this idea and help you understand how am I talking about it, how does it relate to what we are really discussing, that's what I will get to. But before that, I want to ask you one more question, which is, in our earlier examples, I just mentioned tea and coffee, right? These guys, tea and coffee. When it comes to themselves, like tea company and coffee company. So if this is the company that makes tea, and now they get leaves from tea farmers and tea leaves, and they'll process it, dry it, and make tea, and you will then buy it from them. So that's the tea maker. Now there is this company here that makes sugar, so we already know that makes it interesting. But what about the coffee company? Where does it belong here? The coffee makers.
In the bubble on the right side there.
Yep. Coffee is a competitor to tea, because if you had a cup of coffee, a cup of tea right now, then a cup of tea right now, then coffee is kind of less interesting. And if you have a cup of coffee readily available, you may not be interested in buying tea. That's the nature of the coffee and tea companies. They actually belong in separate bubbles, even though in here I put them in the same bubble. That's right there. I think you understand that idea. So the idea that I'm trying to build towards is that there are these companies like these guys are competitors. Competitors. They compete with each other, tea and coffee. So because if you have tea, then you're not interested in coffee, and vice versa. But sugar is a good idea where you can have friendship with tea, friendship with coffee, friendship with other things. Then it's a very good business to be in, the business of making sugar, because you can then partner with a bunch of different types of entities. And so let me just do not disturb here. Where is my do not disturb scenario? Apparently, let's go find out do not disturb. There, that do not disturb now. Now, next thing is the idea that I will now take up another example in our area. We have a famous company. It is okay. Come on. I said do not disturb, and it's still disturbing me. Isn't that do not disturb? Yes, it is. Something wrong. Something buggy. So let's go take a look at another company in our area. We have a famous company called Microsoft. Then in that company makes a product you probably use. It's called Windows. And so if Windows is being manufactured and they are selling, who's buying it? There are customers who buy Windows. Like sometimes you might have purchased Windows yourself. We don't know yet. At least I don't know whether you bought Windows yourself directly or not. And so they're customers. And then I would like to identify who are these guys. So we have the people that will make Windows interesting. And then there are people that will make Windows less interesting. Who are those? Can you help me identify them?
So I assume the right bubble would be a competitor like Apple.
Apple. Because of Mac OS,
Right?
right? What about here?
Uh,
Yeah, I'm having a hard time understanding. Like, on the one hand, we could say something like loans or a means to buy the Windows product, kind of like what we did for the planes.
Right.
Or is it,
Right. I'll give you an idea. Way of thinking. It's a generalized way of thinking. Is that the moment you have this thing available, that you suddenly want to have Windows. Otherwise, Windows by itself is not interesting. And I'll give you an example.
oh, I see. So would the
Otherwise,
left be the
Windows is not that
computer?
interesting. There is something that complements Windows very well. You know what those things are?
It'll be a device like the
Yes,
computer or
exactly. Right. That's one idea. So, hardware. The fact that you have hardware that will allow you to run Windows makes it interesting, right? So there are people who make hardware are these guys like Dell and HP and bunch of others, right? That's one type of complement. There are other types of complements also with Windows, and those are applications. Like you have Word, Excel, PowerPoint. They're also made by Microsoft, but in nature, they are complements. You also have apps like Adobe Photoshop, Adobe Photoshop, and bunch of other Adobe software. And there are tons of such things that are out there called applications that other people make. Sometimes Microsoft makes. So these are, made by Microsoft, but that's a different team, different organization within Microsoft that is making Windows a little bit more interesting. So that's the idea. The fact that you have now Adobe Photoshop, that you can probably use Windows better. Otherwise, just a plain Windows box with nothing installed. So nobody is interested in, primarily just using Windows. Imagine, you know, this game called Fortnite. You may have heard of Fortnite. The moment you have Fortnite downloadable for free, suddenly Windows becomes very interesting. And not only that, these NVIDIA graphics cards. I hope you understand what I'm talking about. NVIDIA gaming graphics cards, high end, 11 GB, 1080 Ti, 2080 Ti, high end graphics cards. They're like thousands of dollars worth, just the card itself. And you add that to a machine from HP, Dell, or maybe build yourself. And then that machine and this Fortnite game, you add Windows there. And then suddenly everything is a beautiful solution to play high-end gaming. That's what I'm talking about. So this is the nature of the economy in play. Now, one last idea before I wrap up this economics discussion and switch to what we have in mind is the last idea here, which is there are these items. We put them in these 5 circles: the company, the complement, and the competitor, and the supplier. By the way, Microsoft has, mostly for Windows, the only supplier Microsoft has are the employees, because there is nothing else that goes into Windows except the work done by Microsoft employees. They just make code, and the code goes into Windows. That's how the raw materials are. So it's basically code coming from employees that goes into Windows. That's the idea behind supplier. So now we have your customer, and you have competitor, complementer, competitor, and the company. So now question is, can there be a scenario where a entity like this X or this Y, can they belong to multiple boxes? Can they be a situation where this X can be a supplier and X can be a customer also? Absolutely. The employee of this company, Microsoft, for example, can buy Windows from the company itself. They will make it, but they can also buy it. So that's a scenario where this X person can be an employee and a customer at the same time. Can there be situations when these entities can also be in multiple boxes, like I just showed you an example? This person, employee person, can also be a customer of Windows. So the question I have is, can there be a situation where this entity X is also an entity X? Sorry, no, that's not how I should say. So hold on, let me say it this way. You imagine this Windows company, or the Microsoft company that makes Windows, and in your complementors we had Dell, we had HP, and there are more like that all make hardware, and they are all complementors, but by itself or by one of themselves. So let's say HP in here. Now, if you have HP that takes Windows as a license from Microsoft and then sells a PC to a customer like you and me. Now, in that scenario, here is your Dell. They are now suddenly a competitor to HP. So the question is, can Dell and HP be always called competitors? Is it always true that they are going to be a competitor in scenarios? Or can there be a situation where Dell and HP, they are really good partners, good friends, partners, and they like operate hand in hand like BFF. That's the way to say it, I think. If they operate like BFF, can there be a situation when companies like Dell and HP and others that are strictly, competitors, because these guys make PC machines, these guys also make PCs, and they are all, trying to go out to the same customer. So if there's a Dell computer, then this HP computer suddenly becomes less interesting because there is a Dell also now. So I don't know which one to buy. And so the level of interest in HP box goes a little bit down. The question is, can HP and Dell be in a situation in which they are really good friends and partners and BFF? Is that possible?
Is it possible? I would think so, maybe.
Yes, it is definitely possible. So it's a trick question. And I'll tell you now, give me an example of where there may be a situation where it is possible. So the way to think about this is like this. You have these, complement and compete, and your company and customer and supplier. So whenever you have a relationship that is, on this side, then it is typically competing in nature here and complementing here. But whenever you are together here, then you are BFFs. That's the way to think. Now, identify a situation when either here or here, so they're BFFs. That's the scenario that I'm just letting you know by what I call a way to think. And what I'm really trying to hint at is a scenario where you will have a situation when Dell and HP will both together be in the customer segment when they will do something with Windows. They will like to buy Windows as a license to put on their PCs. And now in that scenario, suddenly Dell and HP and other companies like Lenovo, and there are a whole host of them, like maybe I don't know how many, ton of them. They all suddenly become BFF, and then that negotiation that happens is that they'll band together as BFFs and negotiate with Microsoft, asking the price of Windows to be brought down from whatever $50 to $10 per license, and so even sometimes even lower than $6. That's the kind of negotiation they will actually hold, because they will band together as BFFs and try to negotiate with Microsoft, trying to bring down the license of Windows down from some number to even below lower number. In that scenario, you have these companies that are traditionally competitors suddenly become complementors or supporters or friends or BFFs. So the key learning takeaway of the cooperation book is right there, is that there is no such thing as always cooperations or always competition. There is no such thing. You can have multiple companies play the role of cooperators, complementers, and competitors at the same time. That is the reason why the name of the book is like it is. Cooperation. Cooperation and competition at the same time. That's the idea. Now it happens all the time in every single industry. You have to understand the dynamic of the situation basically goes down to this value net. If you're playing in this direction, you will either compete or cooperate. But if you're here, you're likely to be banding together to negotiate. And similarly here. And that scenario also holds true when you have Dell and HP and Lenovo trying to negotiate with Intel company, asking Intel to bring down the price of a CPU low. They band together as best friends and negotiate with the Intel company so that they get a low price CPU, so that they can sell the machines cheaper to their customers. So that's the idea. Cooperation and competition at the same time. This happens, by the way, you will observe it now that I have discussed this with you. You will observe in real life, these things will happen. Now, why did I discuss this with you? Is the reason is that I want you to, whenever you do a work, like a new work in your company, new work item, whenever you have a new work item to do, because you're really essentially asking, somebody's asking you to build something, right? Build something, create something for the customer. So that's a new work item for you. And so you are in your company, and then you are trying to create something as an employee. And you don't have to worry too much immediately about these two sides. But of course, now that you have seen this picture, the value net, you should think about those aspects also, the complementary nature, complement, and the competitive nature. It may not be directly relevant to every single example that you do, but you should think about these things. Because what happens at the end of the day is that in the company that you work for, there will be a variety of things that the company needs to do to take care of the customer, to take care of the complementor, to take care of the supplier, to take care of the employees. And there will be applications in your company where the company will focus on a product called SAP to manage the supply chain, and also e-commerce solutions to manage engaging the customers, to sell airplanes. You might have service delivery options, like, how do you service a plane after you sell? So there are, commercial aviations division you have in your company that handles customer service after the sale. And, you have elaborate systems to make sure that planes keep flying all the time. They're rarely on the ground because you are actually proactively managing every single plane that flies worldwide. And if a plane needs a particular part, you will make sure that the part is delivered to the right destination even before it is needed, just in time so that it can be used to service the plane so that the plane keeps on flying. And there are these equipments and machines and services that you have running already in your company that handle, customer service primarily, to service your customers, to make sure that they are happy, that they're able to buy, they're able to service, and the end-to-end cycle of using a plane from the Boeing company. That's the kind of services that you already run. Now, your new work item needs to be understood as to where exactly does it belong. Is it serving your complementors? There may be a case in which it may be. There may be a case in which it is related to your entire supply chain of items that are coming into the pipeline, into your assembly line in the Everett factory or other factories you have. And eventually it reaches the end customer, like Alaska Airlines, for example. And you have to understand at each stage of the transaction, there will be applications that will, like, I'll give you some examples here. Let's go back to the picture. The picture may have some examples. So let's go see where they are. Where is that? I have a list of applications that I think I would like to point out to you. That application list is opening up in this. So here is a list of applications that relate to customers. Scenarios where you have applications running that handle sales management, shipping, logistic, return. This may not apply to Boeing company, but maybe it does. I have no idea what you use internally, but you probably know these things. You don't probably, click a button to buy a plane and then ship it like Amazon does, but I'm just saying that there may be other cases in which you have such solutions. There are things like brand management, customer relationship management. You have probably elaborate systems on maintaining relationship with airlines across the world, and that requires CRM systems. You have, customer relationship management systems in place. You probably use Oracle or Siebel or one of those guys, one of those solution sets. I don't exactly know what you use internally, but you probably have them. You will have situations where you will expect money to be received from companies that buy from you, and that will relate to account receivable. And so basically financial systems that you will put in place. From the point of view of looking at the competitive landscape, you may not have applications that will help the competitor, but you will probably very likely have applications that will excuse me, keep an eye on what the trends are in the industry, what may be Airbus doing, or what are the competitive intelligence information that you can gather from whatever sources that you have legally that you can gather in every country that you operate, so that you are fully aware of what the competitive tactics that other companies like Airbus may be doing, and you need systems to handle that. And there are systems that will help you gather competitive intelligence in your company that you probably very likely have. And again, I have no idea what you use internally, but there are solutions that are available that will help you keep an eye on the competition legally. Not saying in the wrong way. There are legal applications you can run that will help you understand what is happening, keep an eye on the news coming out, keep an eye on social media to see what other airline companies may be doing, so that you can learn from those trends, understand what can be done, and take action proactively. Similarly, there will be other IP implications to suppliers. For example, you will have applications that will handle supply chain management. I identify the exact amount of inventory needed for a particular item so that it arrives from the supply chain into your factory just in time. This idea of just in time is a very important one. You may have heard of this phrase before, and that idea, let's go search it, JIT. This idea of JIT is there. So this is a manufacturing phrase called just-in-time production, again organized by started by the Toyota production system methodology. The idea here is that you will create a system that will reach your location where the item is needed just in time. And let me elaborate a little bit on this idea, because I think it is relevant to the relationship between a company and its supplier. So you have to receive certain items from here to here. And you don't want to be receiving too much of those items, because what happens when you do is that you have to pay for it a lot of money. And then these items are sitting here, inventory, and not doing anything interesting. And that is money lost. And so you don't want to be doing that. So instead, the right way to do this is to not waste money like this, to not get so many of these items accumulated in your company unnecessarily, and not lose money, but instead arrange a system when you mathematically calculate the optimal order quantity. Needed from the supplier, and have that quantity in exactly that same amount into your company, available to you at the right time, at the right place, in the right quantity, available to you as a guaranteed delivery. And then you pay, of course, provided they give you the item in the optimal order size. So how many items that you want, what time, what place, you will have to decide that. You can calculate this quantity mathematically. And I'll give you a link to read if you're interested in that direction more. And that link is simply optimal order quantity. And that you can calculate. By the way, there is a software, or there are many software that will calculate these quantities from your existing systems. And there are let me give you some examples. First of all, there is math involved here. Economic order quantity, this is the math. You can see the math here, see what it means. And these numbers will come from your internal supply chain of manufacturing assembly line. That will help you understand how much quantity should you order. So that translates to the simple idea, which is this. How much of something would you want to have in your factory at the right time, at the right place, in the right quantity, so that your factory floor keeps on operating without accumulating unnecessary inventory. And that technique, the math that I just showed you here, this math called optimal order, economic order math, is already calculated and implemented in a variety of software. And that software is called supply chain operations software. And there are many companies that sell such software. One of them is Oracle. And you probably will recognize some of these applications running in your company internally. I'll just pinpoint a couple of these guys. So Oracle Supplier Network, Oracle E-Business Suite, you might have these things running in your company. So here is your supply chain management software from Oracle. I don't know what you run internally, but this is a good one. You probably run it already in your factories. And from an IT standpoint, you need to be running these services internally for your suppliers so that they give you optimal order quantity in the right location at the right time every single time without fail, so that your flow of logistics in your factory keeps on flowing correctly. That's the underlying idea. And the reason I bring it up is that I want you to think like this and make sure that you are paying attention to those four directions that I'm pointing out again. Basically the same things. Like here, suppliers, you want to pay attention here. The customer, you want to pay attention to the customer needs and create applications and services that they are taken care of. You want to take care of your suppliers, including your employees. So there'll be employee systems that you probably, in other words, they're called HR systems. You want to take care of your HR system so that will help your employees effectively. So that system is what you need to be running internally. You probably already do. And you want to help out your complementors or your cooperators, and keep an eye on these guys, on the competitors. And for every single action in each direction here and here and here and here, you need some application or maybe a bunch of applications to make this thing completely automated in your company. And by the way, you have it already. And many of you, without realizing, actually are managing these applications and these services for either actual customer like Alaska Airlines, or maybe internal customers within the company. So there is, the company is gigantic. It's a big company. So then similar structures you can actually create in a smaller scale within here. Like for example, a portion of the company as opposed to the full company. Think of the company as a gigantic company. So you may not actually capture the entire gamut of scope of the things that are at play at a given time, because we are individuals and we are small compared to a gigantic organization like the company itself. But this concept applies every single time. That's the point I'm trying to drive. I'm also saying that, at every single direction that you look at, there will be some applications that you need to be either creating, building, running, or I should generalize it. Three ways you can do. You either build, or you purchase something, or you rent or acquire, in other way, partner. So the build, buy, or rent are the three ways of consuming services from and helping out these four connecting, what I call stakeholders. So you have to help out your customers. You need customer service software. You need customer relationship management software in this direction to help customers out. If you want to help your suppliers, you need HR systems to be running, and that direction will help your employees. You need your supply relationship management in place. You need to have, the Oracle e-business suite, like I mentioned here in this picture, Oracle supply chain management products, procurement and lifecycle and supply chain planning, logistics, order management. Those systems need to be running internally to your company, not specifically saying you need to run Oracle, but you need to run some to help your suppliers. And that will be this direction. You need to also run collaborative tools to cooperate with your complementor so that they are also happy, because their existence, the fact that they exist, make your customer a little bit more interesting in your product. And so you want to keep them happy. And so you need to make sure that you put, partner extranets or other relationships with your existing partner companies to help them do business with you together. For example, help a GE Capital come up with a loan package that helps Alaska Airlines buy a plane. That will be one example. But in each of these directions that you're looking at, you will have some application that either you will build or buy or rent and then operate in the context of IT department in your company. So that's what IT does, or helps run the business, helps run applications. And what exactly business is? It is the same idea like I just mentioned, like here. That's what business essentially is. You need to keep track of these, and these, and keep an eye on those guys, the competition. You don't cooperate with them, you don't have to, but keep an eye. And in other three directions, you make sure that you operate smoothly so that effectively you are making this customer really happy. That's what you want to accomplish. And so the key takeaway from all this discussion is like this. If you find that you have a new work item assigned, and that is very common in most big companies, very, very common in almost every big company that I have seen. People will randomly assign some new work item to a group or to a team and say, hey, why don't you do this? Okay, so you got that new work item. But the first thing you should ask is, how does it help my customer? And how does it help this direction and that direction? Or maybe does it fit into the other way to think about it? Is this new idea that you're talking about that we should be doing, does it fit into this chain of things at our disposal? Does it fit? or it doesn't? That's the real question you should actually ask. Does it fit the business that we do here at all? Yes or no? Yes or no? And if it doesn't fit, then the simple way to think about is to say no. I will not do this new project because it does not fit. That's the takeaway. That's the reason I built up all this discussion for you to take this in your frame of thinking whenever there is a new project comes along that you want to start something, you want to think whether it actually helps your customer, your supplier, your complementer, or helps you in keeping an eye on the competition or not. If it does not, say no to that because don't waste time. Everything else is irrelevant. That's what I'm saying. So that's the key thing you should remember. And of course, you read that book that I mentioned called Cooperation, which is somewhere here. That book, these guys wrote. It's a good textbook. It's actually a very short book and it's a very good book. So it should not take that much time. It's available. It's a 290 pages, not that big. And it's an old book. So, and there is no technology here. So nothing, no command line, no nothing, just concepts to think about and understand. That'll help you in general in everything you do in business of any sorts. So that's the idea that I wanted to express, which is to help you understand how to think about when to say no, when to say yes of any new project, that whether it fits into the game or not is the key way to think. And that will help you in doing the right thing. Because if you're saying no to something, you have a basis as to why you're saying no. And then you're actually doing things a lot more efficiently by saying no to wrong things and say, I'll not do it because it doesn't make sense, because it doesn't help any of these stakeholders. And so if they, doesn't help my stakeholders and it doesn't help me in improving my eyesight on the competition, I'm not doing it. Doesn't make sense. Don't waste time. The company saves money by doing that, by saying no. The company benefits when you say no to something that is, I call, silly. Because if it doesn't fit, it is silly in my point of view. I am probably radical, but that's how it should be. I actually am radical. I know that. So don't do silly work. That's the key takeaway. I know you don't, but this is a frame of reference of thinking about how do you say whether a particular item of work is silly or not. And that's the takeaway. What do you think about this idea?
I think it's good. It's a good concept to keep in mind.
Okay.
Yeah, I agree.
Good to know. So with that, I will now stop talking about this and actually move on to the ideas of actually real examples. So let me just, by the way, take a note of this name, Brandon Burger Nail Buff, and actually buy that book, or maybe it's available to you in your library. So just pick it up and read. It'll be a good read. And I will close out. And so you should also see this sheet actually describes a variety of applications that you will see running in your company, and they are what they are. So various companies do things differently. I don't know how your company does, but you probably do these things almost in every single place wherever you have each of these four elements that I mentioned around your company, which is complementer, supplier, customer, and competitor. Those four bubbles, like here at the very beginning of this discussion we had, like this picture. These are the forces that shape business, by the way. So with that, I will now close that window. And now I will talk about something a little bit more real. This was, by the way, I hope it was real. When you actually relate to something that you can take it to and apply to any company, any business, anywhere. This is the general framework of thinking about things. Now let's talk about concrete things, really concrete. And that is Now we have been discussing about some applications that you want to run in some, WordPress, MySQL, this, that, Redmine, Postgres, God knows how many of them. So bunch of different things. And they will create applications that you give to your customer. And they're useful to understand. They're very, very, very black and white. They're hands-on. You can actually see these things. But let's now understand and take a little step back and think about real examples of big companies that have built applications and use cloud to create whatever is needed to make their application go live to their customer. That's the kind of scenario I want to actually think about. And so this will be a case of, rather, this will be a case discussion, a discussion that will not involve direct hands-on work on a command line, but more of understanding how will a customer need be met. How do you want to meet the need of a customer from a company's perspective with a concrete need? Concrete. It has to be a real example and a real customer. A real concrete need has to be defined, identified, and met in the context of the cloud. And we will understand what does it take to meet that need for real by designing, or at least attempting to understand what needs to be designed in form of an architecture to implement something that will meet the need of the customer. That's the kind of discussion we would like to have, at least for 2 or 3 cases. There will be more cases, but until you get bored. And so we'll go back to our command line again if we need to. And we will. The command line is not going away, but just want to give you higher level pictures of real customers, real companies doing certain things in a way to meet the need of a customer. And so we will begin with a very well-known example of this company called Netflix. You heard of this company, right? You know them. You probably use their services. And so with that understanding, I'm going to make some assumptions. The assumption, one of them is that you are the customer. So you have a need. And this company is serving that need. So what is your need? By the way, is the assumption that you are a customer correct? Are you a customer?
Yes.
Yes.
Oh yeah, but very likely I am also a customer, although I don't watch movies. But yes, I am a customer. I have a login. That's how I describe. So yes, I do have a login because it is given to me by my phone company. T-Mobile gives it for free, so I have it. Well, I pay for T-Mobile, so it's not free. Yeah, I do pay. So let's identify the need. So what is the need of this customer? Like you, me, and people like us. What do we need?
Television programming, entertainment.
Yes, basically watch, video entertainment. We want to have video, not just audio. So you have to be able to watch video entertainment. And there is another characteristic here, on demand. Right?
Mm-hmm.
On any location. At any time. On any device. I'm just stretching this demand now, right? Because that's the expectation people have come up with over time. This is not how it started, by the way. You probably know that it used to be a company that used to send DVD in the mail in a red envelope. You probably recall that. Maybe you don't. There used to be a thing called red envelope, and it used to come in the mail, one at a time, sometimes 2 at a time. And you got the mail. And so when you got the mail, you put that in a DVD player. and then you have it connected to a TV, and then you press the play button, and then you watch. That's how it used to be. Do you remember that? Some of you, maybe,
I do.
Yeah,
maybe you do.
I,
Yeah, that thing is gone, like completely. I don't see it anymore. But that's the dream that Netflix had to begin with. Is this dream that they have realized? Is that they would like people to be able to watch video entertainment on demand, any location, anytime, any device. And there is one more thing here: without fail. That's the vision that they had to begin with. Now, if you go back in time, that's not what they're doing. They were like shipping items in the mail, and then ouch, there was this thing called one or two at a time, sometimes three at a time DVDs you can receive. So you can like receive one, two, and three DVDs in your home, and you pay them some money every month. And there used to be a queue, QUEUE. This queue will keep track of what your interest is in terms of the movie priority queue. I would like to watch this movie, then Y movie, and then Z movie, like that. So I'm very, very vague in names of movies because I really have to think about what are the names of the movies these days. And so that's, you need to basically sort and create the queue. It's actually a sorted queue of your interest. So if you have these items in a queue that is on their website, by the way, there used to be a website and where you set your queue. This is the priority queue. And so if that movie is available, they will mail it to you depending on your package. It's one at a time, two at a time, three at a time, whatever your package is, with like $9 or $20 or some monthly. And then based on that, they will send out 2 movies, 3 movies, depending on what you do. And then when you have this movie X and Y and Z available here, then you watch the X movie and then you return it. Then you ship it back to them. And so then they will, send you the A movie here in the mail. And then you watch the Y movie and you ship it back to them. And then they'd send you the next movie you might have in the queue. So that's your queue of movies that you wanted to watch, and you make a priority list of sorted order, and you can adjust your queues, go up and down depending on what you might change in the preferences that you might have. And that's used to be the system. Now this system had a lot of problems. As you can understand, the vision was here, and they have met. By the way, the vision is, they've met. They've done a fantastic job, as you can understand, and you already know that. You can see the fantastic job by looking at this thing. See how beautifully they have done. In the last few years, it's amazing growth there in the stock price. So I'm talking about older days, like 2008 time frame, all the way through now. It's amazing. In fact, this online streaming kind of started already in this time frame, in this time window somewhere here. Then it took off. That's what you're looking at, and you've already seen the Netflix stock price. Now let's understand in the older days what was the scenario in terms of what their vision was, like here, and what they were trying to do at that time. So at that time, they had a website which basically managed, your customer login, password, and queue management here, and they had a way to collect money from you on a monthly basis. They had membership, and based on the membership, you will either get 1, 2, or 3 at a time. And then they will have these DVDs shipped out to you. And so if imagine this is the map of the US, for example, and I'm bad drawing. This is your USA. And so here is Washington State, and here is your North Carolina. And so in the state where I live, somewhere here, And so I used to receive a DVD in the mail from a location here. So that location used to be in Renton, where your factory is, somewhere close to that. And so that's where the DVD used to come to me in the mail. And that was a regional hub. And like the regional hub of DVDs, so like that, they had regional hubs, worldwide, and not worldwide, in the US wide, I should say. I don't know exactly where the hubs were, but these hubs were distributed nationwide. And that's what primarily was used as a place to ship out DVDs to people in the area. And they will, basically do the transaction between the hub and the customer, and then return it back to the nearest hub. Now, in the process, they had a data center. The data center ran that website, which you probably don't remember, or maybe you do. And that website did nothing but just looked at the queue of the movies that you may be interested in watching, and keep track of how many movies you have in your home, and how many you have watched, and how many you returned, and like that. So the game was that they run a website in a data center, and they have a ton of DVDs, like a ton. And this ton of DVDs was stored in various regional hubs, and they were shipped out. They sent it back and all that good stuff. At that time, if you look at Netflix in the old days, Netflix was competing with somebody. Do you know who was competing with? Do you?
Was it Hulu or were they around then?
Hulu, did you say Hulu? Hulu is a
Yes.
new company. Like, I'm talking about old Netflix. Who did Netflix compete with on older DVD days?
Oh, Blockbuster.
Yes.
Are they even still around?
I know. Are they still around?
I don't know.
Maybe there's one or two stores left, but that's it. Yeah, so they're dead. So Netflix basically systematically killed them. And Netflix had a cooperator, that was the post office, right? So it helped Netflix deliver DVDs to you. And so the DVD days. So the game was to kill these guys. That was the business game. And so they get movie from the Hollywood, and wherever I'm generally calling it Hollywood, wherever the movies are produced. I don't know where they come from. Well, I do, but I'm just calling it Hollywood. So post office helps them, makes it interesting, makes it possible for you to receive DVDs and mail. And Blockbuster was doing something that was obnoxious. You know what they were doing at that time? Blockbuster, obnoxious things. What was that thing that they used to do that was really, really hurtful to you?
Ridiculous.
Huh?
Was it late fees?
Yes.
Yeah.
It used to hurt, literally hurt. And so people hated that. So what did Netflix do? They said zero late fee. You get A, B, and C movies at your home, you keep them until you like, perpetually if you like. Just keep paying us $20 every month. And you can keep the movies for however long you like, no late fee. If you want to watch the movie number D, then you return one of these guys, and then we'll give you the D movie, and then you watch D, and you keep the D CD with you, like all day long. I mean, however long you like, no late fees. That was one big differentiation. The other differentiation was that, if you have, look at a typical Blockbuster store. If you look at our map, this is the US. And however many regional hubs of DVDs that Netflix had, imagine now how many points do we'll have to make for every Blockbuster. It'll be a whole lot more Blockbusters, right? Because every city will have at least one. So there'll be a lot more dots across the nation where there are Blockbuster stores. So it's a different game. A Netflix DVD hub is going to be a big, gigantic building, basically a warehouse. There are no customers going there, and all they do is just store DVDs. Whereas in the Blockbuster store, you have, you know, the latest and latest, newest movies in the Blockbuster store, and you have only so many of them. Whereas in the warehouse, you can have a large number of movies stored. You can afford to do that here, not here, because if there are like 2 million movies, 2 million DVDs, you can store them in a warehouse in regional hubs across the US. But can you store 2 million movies in a Blockbuster? Not possible. Purely not possible, because it is impossible to fit in a place where every Blockbuster carries 2 million DVD choices. So they have this advantage of choice, but these guys did not. These guys carried newest movies. These guys carried choice. The way to describe this in economics is called long tail selection. The idea is Blockbuster will carry movies that are that are very, very popular, and they're in big quantity. They will carry only these movies, like the top 10 movies or maybe top 100 movies, but that's it. Whereas Netflix will carry 2 million movies, and it will probably exclude these movies altogether. They just have a choice of a large collection of movies available for you to pick and choose from, and you create your list, A, B, C, D, whatever you want to watch. That's your queue from the long tail. Now, if you look for the word long tail, you will get a better picture. What I'm talking about is, what is long tail? Not tile, long tail. You will see what I'm talking about here. Long tail is a statistical term, which is basically an indication of product's popularity compared to the head versus tail. So there are certain things on the head side, the red items versus the yellow long tail is the concept of popularity of a movie versus its long list of not so popular movies. That's what you're looking at here, is this shaded area, which will contain your tail or the long tail movie selection. It's a very long choice, millions of items, not as popular. Only the very, very highly popular 10 or so movies will be available in Blockbuster, but not on Netflix, and everything else will be on Netflix. That used to be the way that they differentiated. The other scenario that they could do in Netflix, that they gave people a choice, which is this long tail that Blockbuster could not. What Blockbuster did do was, get this segment of movies, like maybe 100 or so, and they had to compete very heavily in that space, because first of all, the movies are new, which means the movie royalty is high, which means it's very expensive to get a DVD in the store for them to rent out. And then on top, you have to make sure that you're profitable. So you make sure that everybody wants to get that particular latest movie that comes out. So all the top movies are right here, and people will not wait for the movie to become available. But you cannot fill up your Blockbuster store with million copies of each of the top 10 movies. You cannot do that. You have to have some limited number, because otherwise this becomes very unaffordable. You may carry like 10 or 20 copies of every top 10 movie or something like that in every store. And then you run into a problem. People will take the DVD out and not return it. And so you have to apply late fee right there. And so you apply late fee and then make your customers really, really unhappy. And they will grudgingly return it and try to avoid late fee, and it's just a nightmare. That's exactly what Netflix tried to avoid in their game, is to give people a choice and not charge late fee, because they could afford to carry a long tail selection of movies in their limited locations, which they did not have to have. Only regional hubs need to carry DVDs. So that was one game that they were doing. Another scenario that they were aware of, which was a problem for them, and also for Blockbuster, for problem for both, is that there is this thing called, what's it called? Yeah. So this is the item. This is a person. So this guy is a person. His name is DVD John. And what he did was he created an open source project called DCSS. And what this does is it decodes the content scramble system used for DVDs. So decoded that. What does that mean? He wrote this software called DCSS. And this software is a part of your Linux distributions these days. It's there already. And so what this basically means is that you can use this software in open source to reverse engineer and decrypt the encryption used by DVDs. So DVDs used a content scrambling system to encrypt the movie itself. If you have a DVD player, and you put a DVD there, and you try to connect to a tape recorder or a VCR and try to record, you will find that it doesn't record. You may have noted that, or you may have heard of it, or maybe you haven't. But let me tell you that it is not possible to just press the record button and record a DVD onto a tape recorder. Not possible. Why? Because of this content scrambling system comes into play. This is also known as Macrovision. Macrovision CSS basically prevents piracy. Piracy is detected and prevented. So all the manufacturers of VCR and manufacturers of DVD player will collaborate to make sure that they implement the Macrovision software in here and here, and therefore copying was not possible until this DCSS came along from DVD John. And as a consequence, this software that DVD John created allowed to remove the CSS, which means now you can copy. Not only copy like a tape recorder or tape VCR, but also create a copy from a DVD to a file, like video file, for example. Those kind of files. That was possible with DCSS. And that led to a lot of piracy. And what happens when you have piracy? Can you tell me? If you have customers getting DVD from you and DCSS and creating a file, they will just take a DVD, A, B, C, create a file, A.mp4, and return the DVD back to you. Get a file B, create a file B.mp4, and give a DVD back to you. C.mp4 back, and like that. That used to happen. That's the idea of piracy. That's a big problem for Netflix. Do you know why that is a problem? You lose money. Simple answer.
Yeah.
You lose money, right? You lose money. Your suppliers are very unhappy. Hollywood is very unhappy about it. So they take notice of this fact that this is happening, piracy is happening, and they want to find a way to prevent it. That what they have eventually found out a way to prevent it now. But that used to be the case when the DCSS came along, that it led to a lot of piracy, and that is something that Netflix wanted to avoid. This was a problem that even Blockbuster had. People would just rent the movie, create a file, and just return it, and you're done. And you also avoid late fee, and you have the movie, you keep it, and you play it as many times you want. That's the bad idea of what was going on. So these guys wanted to avoid that. And so they wanted to really go back to the point which was the original vision, which is we want to be able to expand on this vision to avoid piracy. So if that is the scenario you want to implement, and you are already seeing that a scenario where your internet service providers that are there, Comcast and Quest and bunch of other companies that provide basically ISP, internet service providers, the bandwidth available to common customers over time has been growing steadily. And if you look at the bandwidth available to my setup, I think I have like a gigabit internet in my location. And so you can run speed test or just say fast.com on an iPad. It will be not indicative of the full bandwidth, but it will get you good idea about how much bandwidth do I have. This is the residual bandwidth. I'm running a full video conference on the iPad, and I'm still getting 310 on the Wi-Fi. That's limited by Wi-Fi. Wi-Fi cannot actually do more than this. If you connect the iPad using Ethernet, you can see a 1 gigabit speed. That's the kind of evolution happening in the industry where ISP bandwidth is steadily going up over time. It used to be low, but it has grown over since like 2004. It used to be like maybe 3 Mbps, 3 Mbps in my home, to now it is 1000 Mbps, or rather 987 Mbps, I should say, Mbps. So that the bandwidth availability has tremendously improved over time. That's one trend you're observing. Another trend you're observing is that these things called cloud computing is kind of starting, with Amazon Web Services starting to come up with this scenario called cloud computing suddenly become available to us. So you can see that these things, as you notice today, is kind of fairly comprehensive, and lots and lots and lots of services pop up. But earlier days, it was just this EC2. That was the case. There were a couple more, but I'm using Amazon for a long time, really long time. I've seen this evolution of this Amazon Web Services as one of the first ones to create a web service called cloud computing service, available on AWS. And so that's another transition you're looking at in the industry, allowing cloud computing to happen. You're seeing internet services providers bandwidth availability to consumers improving steadily over time. You see another trend happening, which is devices coming along very well. Lots and lots of devices that will allow you to play videos, not just your classic DVD players, but also Blu-ray players, and all of them, all the rest of them, like iPhones, iPads, this and that, and TVs and PCs, and God knows what. Sony, PlayStation, Nintendo, Wii, Nintendo. I don't know, but bunch of them. You can see the list, but so here is a list. You already know what I'm talking about right there. Here is a list of devices that are supported on Netflix. And so this is a fairly comprehensive list. You've got streaming media players from these companies, Apple, Chrome, Fire TV, Shield, and Roku. You've got smart TVs from these companies, your gaming consoles from these companies, set-top boxes, Blu-ray players, smartphones, PCs and laptops, and Macintoshes, and bunch of devices. That evolution is happening on the side. We have cloud computing growing. We have ISPs improving bandwidth coverage, and so these things are happening. And now we want to accomplish our desire, ultimate goal for the company, which is, again, let's go back and review that, which is, I think you already know, so I don't need to repeat this idea, but just remember that this is what I'm talking about, the ultimate goal of the company. that they had at the time of DVD days. Having seen this and so having that, we understand this very clearly. So I will not come back to this portion again, but I'll just call that as our vision at that time. So the trends you're looking at is the thing that I just mentioned, which is recap. The recap is we have bandwidth improving, we have devices available, we have Amazon Web Services starting off in like 2007, 2000, no, 2005, I think 6 time frame, something like that. They started, and I think I have an account since 7 or something like that. So that's the scenario that you're looking at from that time frame. Cloud services coming along, your bandwidth increasing, devices available. So we want to eventually implement the ultimate goal of the business, the vision that Netflix had. So now I will ask you a couple of questions. In order for this company to create a vision, they need to really enable a scenario where you have a customer who has a device in their hand. These are the devices. And here is your company, Netflix, and they want to be able to not ship a DVD, but instead stream the movie to you on this device. And you know the vision, any device, anytime, any location, any movie, whatever you feel like, all the things that, reliably do it every single time without fail, all that. So that's what the vision that they wanted to implement. And so if you want to send a DVD, or rather not send a DVD, you want to stream, so you need to build something here that will actually enable the streaming part. And what would that be called? What would you call it? The thing that streams. There is something here that streams. What would you call it? I call it streaming service. You have to build a service that will stream any movie that this guy thinks of. And just stream. That's the idea, right? You come up with an idea that I want to watch XYZ movie or X movie, and so you just start streaming X. And you have bandwidth available, you have cloud. So you want to create a service like that in the cloud. Or maybe you want to create a service not in the cloud, but your own data center. So the questions I will have are, how would Netflix decide whether to build their own data center or use Amazon Web Services as the only cloud at that time? So we know that they chose this. But the question I have for you is, if you were there in their place, what would you think in coming to this conclusion, whether I go this way, build my own data center, or I go that direction and not build any data center, just use the cloud? What would you think about in making that decision? Because that decision has to be made by somebody like you.
Probably the cost.
So cost comes in 2 parts. One is upfront cost, and the other is operating cost. Like you keep spending certain portion of the cost every single day. It's a recurring cost. It's also called the operating cost, operating expense. And sometimes you have a cost that is like upfront. So you spend $10 billion on something upfront. And then you have an operating expenditure, OPEX. This $10 billion upfront that you spend is called CAPEX, capital expenditure. And so those are the 2 costs. What are you talking about when you say cost? There is cost to Amazon, there is cost to building your data center. They're structured like this. You want to build a data center, which means you need to buy equipment, you need to spend all of that money upfront on a building, and some on your IT equipment, some on your bandwidth for your source. And so your building that you will create, and you will spend like maybe $10 million, $100 million. I don't know how many, I don't know how much, but a lot of money upfront. That's your capital expenditure. That's your data center scenario. If you go data center. On the other hand, if you're not using a data center, the cost structure is very different. It is definitely not this because you don't have any, but you spend a certain amount of money every month, every day, every hour. Goes on up and down depending on consumption. How much of a machine can you, how many of those machines are you using up over time is what you pay for. And this is your operating cost, operating expense, also known as OPEX. That was CAPEX. So from a pure economics perspective, which is the right direction to go? Here or here? Well, let me describe how to think about these things. Give me a second. Yeah, so the way to think about these things is very simple. The way to think is that you want to make profit. That's what business is about. The profit happens when you have money coming in, money going out. And this number is bigger than this number. That's when you make profit. This is coming in, this is going out. And the difference in minus out, that's profit. So you want to make that profit. That's the idea of a business. So now if you take a look at these two pictures, spend $10 million up front. That's your money going out. And how much money comes in? You subscribe to Netflix. You pay $9.99 per month. It's $1.99, right? This is $10 million. So money coming in, money goes out. That's one scenario. The other scenario is, and by the way, there will be more customers. So number of customers multiplied by number of customers. And you're a new company, so nobody knows about you. So the number of customers is very small to begin with. So you have no idea how many customers you will sign up for, and so that's a small number. So you have a small number multiplied by $9.99 minus $10 million. That's your profit. Basically, it's a loss. It's a small number multiplied by $9.99 per month. And this is upfront. So you immediately made a big loss. The moment you upfront spend a lot of money, you have no clue when will you make profit. Literally, you have no idea. You don't know how many customers will come to your service at what time, when, which year, which month. You have no clue. You're totally clueless. Any new business that starts like this is clueless. They have no idea how many customers will actually come and sign up on a $9.99 monthly basis. And then customers are very fickle. If they don't like something, they just cancel the service. And then you're screwed again. That's the idea behind capital expenditure. It's a bad idea because you're guaranteed to make a loss immediately. On the other hand, you make no capital expenditure and everything is operating expenditure. Now you get some customers, maybe two. So you make 2 times 999, you make $20 per month. Awesome. I have two customers. So I'll get two machines, maybe one machine, $5 a month on DigitalOcean. I'm just exaggerating right now, but just saying, spend $5 a month on a DigitalOcean box, run it for a month. These guys are paying me $20 a month. So I make profit right there, $15 per month. I'm happy about it. At least I know I made a profit as opposed to this immediate loss, which is not chump change. So that's the idea behind using cloud services, is that you spend money on operating expenditure, not on capital expenditure. Capital expenditure is a bad idea. I mean, not always, but at least in this example, it is a bad idea. It is bad because it is idiotic to spend money like this. When you have a solution available to you, which lets you like spend $5 a month, create a service that will make two people happy. And this is like a minuscule example. I'm just saying, but you can scale it, make it like 2 million customers and make it, 5 million. That's not bad. It's still good. You suddenly make 15 million a month. Just saying, you're still profitable. You're now making $15 million a month as opposed to $15 a month. But because you scaled your customers from 2 to 1 million customers, so you suddenly become a $20 million per month revenue, $5 million per month cost, and here's your profit. So you're happy about it. That's the way to think about cloud. That's what Netflix actually did. They decided to not build any data center whatsoever. In fact, they closed down whatever they had and just moved on to AWS left and right, every single thing. Absolutely nothing to do with any data center whatsoever, and just purely use Amazon Web Services Cloud. Even today, they use Amazon Cloud. All of it. It accounts for about 15, Netflix, by the way, accounts for 15% bandwidth on the internet. That's a lot of bandwidth. Like people hog Netflix. People do binge watch. I've heard, people do that. They'll take a movie or some I don't know what CDs, and they just watch back to back. You may have done it. I just don't do it. But that's the idea. So 15% of internet bandwidth is Netflix. That's a lot of bandwidth. And so that is a lot of cost, by the way. But of course, that cost is more than offset by the revenue that it generates from customers like you and me who pay for these services. So that's the underlying idea behind using cloud on the backside, cloud on back end, where you will create machines that will render the movie X on streaming to a customer who decide that they want to watch the X movie on their device. The movie plays here. So that's the scenario that we want to be able to create. So on the cloud side or the back side, the way to decide was very clear that it needs to be profitable. And so that's the way to go to begin with. Otherwise, you immediately make a loss and you have no clue when will you make profit. You might, but you don't know. But at least in this scenario, in the case of operating expenses scenario, meaning using the cloud scenario, you're likely to make a profit, even though it may be small to begin with. That's a good idea. Profit is good loss is bad. I think that's a given. So on the other side here, this device, I will have some questions for you. So those days, Netflix did not have such a long list of devices supported. It did not. It had only a handful. There was none of these devices. There were only like a few. Even maybe iPhone was there, I think. Android was not supported. Windows Phone was there but it never worked properly. PCs worked with Netflix, and they had a browser app. So they had these. Blu-ray didn't exist much, but slowly it was coming along. Set-top boxes existed. uh, Game consoles existed. We had these guys, Xbox existed, Xbox older one before this, and then Xbox 360, Xbox One, PS2, PS3, PS4. All these guys, some of them are new, but there were older ones also available like these. And so the question I have for you is that there used to be there is a possibility that you being Netflix can decide to create your own box. Sorry, create a box that the customer will use here, and let them use the box and just stream on the box. So just connect the box to the TV, and that becomes your Netflix box. That's a possibility. That's one possibility. And so the other possibility is to not create a box, which is what Netflix ended up doing, which is to not have a box at all, but instead use the box that's already out there, like these or other types. And Android did not exist because it enabled decryption, enabled piracy. But these days that problem has been solved. So now you have an app for Android on Netflix. Netflix app for Android is available. But here, the question I'm asking you is, should Netflix create their own box or not? How would you think about these things? What are the pros and cons that you need to make in making such a decision for a scenario where you want to provide a service streaming X movie on for this customer who desires the movie? You want to give them a solution. You can either create your own box or not create one. If you don't have a box, then how will the customer watch? If you have a box, then how do you make a decision, this or that? That's the real question I'm asking you. So what do you think?
You're asking for things to consider.
Yes.
So cost would be one again, right?
Yes. Cost of device.
Mhm.
You're putting the cost on the customer. You're making the customer buy. That's a problem because customers may not want to buy. They already pay you $9.99. Then now you're asking them to buy a device also. So that cost has to be eaten by somebody else. Right? That's how you have to think about the cost. Who eats the cost? Is it the customer eating the cost, or is it the company, Netflix? That's one thing to think about. What else? So cost is a negative for this. And so if you don't have the box, you don't have that cost. Fine. But what are the other items to think about when you don't have a box? You still need to have something here. What is that thing?
Internet
Yeah, of course.
activity.
Customer will have internet, and we expect that they will have their own internet service. That's expected. But you need to give this customer with something that they can actually watch the movie X that they have in mind, and you have to give that movie streaming to the customer, and they need to see it. somewhere on some screen. So what would that be if you don't have a box? They have a TV, like most homes have a TV, but the TV is dumb. And so it doesn't connect to the internet. At least the old televisions did not. These days they do. But old dumb TVs did not connect to the internet. So they need to have, to see the movie X, they need something somewhere that connects to the TV. They need a box, right? There has to be some box so they can watch the thing X. So what would that be if you don't create a box yourself called the Netflix box? Netflix box, you said no, that's expensive for the company, cannot really afford to create a box and give it to everybody. He's saying no, no Netflix. So then you have to have something somewhere that connects to the screen that is not dumb, and it shows this person that movie. So what is that thing?
It could be like an Xbox or a Blu-ray player.
Yes, correct. But the problem with Xbox is that it doesn't show Netflix by itself. The problem with Blu-ray is that it doesn't show Netflix by itself because these players, that devices that people might have, don't have Netflix already. Netflix is a new thing, right? New. So the devices that you have don't have Netflix already. These days they do, because Netflix created the application that gets installed on the Xbox that comes bundled with the Blu-ray player that you can download from the App Store on the iPhone or download from the Google Store on the Android phone or download from other location on other platforms. So that thing has to be created. It's called an app. If it is not a device, it needs to be an app that runs somewhere at the customer's location and takes their desire to run the movie X on that device, where you need to have the app loaded on the phone, Android, Blu-ray, PC, Xbox, PlayStation, God knows what, all these things. But these guys need to have the app. So now you can go to the App Store and find the app, pretty much like you've done already. You need to go and find your app there, like that. Now that app is built by, let's see who built it. You go to Netflix, and it is built by the Netflix company. See that? Who makes it? Netflix company. It's not made by Apple. And Netflix has to make this app. Let's confirm that. Yes, the seller is Netflix, right there. You see, this was created by Netflix company, and they charge you for in-app purchases. This is like streaming services, the monthly subscription, and that's the idea. So there is a developer website which goes straight to Netflix. So Netflix has to create the app. If not device, they have to create an app, which they did. That gets loaded on the iPad right here. That gets loaded on the Xbox from the Xbox, I don't know what store, maybe Microsoft has a place to send apps to the box. So the app comes, but the app is written by Netflix. The same idea is extended again, is that you either create a box with Netflix already loaded and you give the box to the customer, or if you don't want to do that, then you use the customer box. Customer box can be an iPhone, an Xbox, or other things like Blu-ray players, But then these Blu-ray players don't have a store mechanism where you cannot like send a app from Netflix into a Blu-ray player. Sometimes they do. I have never used a Blu-ray player, but the most of them I understand come pre-packaged with Netflix app inside in the player itself when you buy the player. So that Netflix has to work with the player manufacturer, for example. Let's go open a new tab, Netflix devices. And so we have to go and look at some Blu-ray players. So here is a Samsung Blu-ray player, LG and Samsung. These guys, they have to include the Netflix app in the Blu-ray player itself. Like LG and Samsung needs to do that work, and they will not do it unless Netflix has to pay Samsung. Netflix, they will have to pay LG and Samsung money so that they will include the Netflix app in the player software, in the firmware of the player itself. So that has to be somehow compensated for. So that otherwise, why would Samsung include a Netflix app in there for no good reason, for a company that is nobody knows about, like Netflix at that time? These days, probably they don't pay. Probably Netflix doesn't have to pay Samsung and LG because the customer is asking at the time of purchase, hello, Blu-ray player, do you have Netflix? And if you don't, I'm not buying your product. That situation has flipped. So now Netflix doesn't have to pay Samsung and LG because the customer is asking the Blu-ray manufacturer to include Netflix to begin with. But at the beginning time, Netflix had to pay money to Samsung and LG to include the app in the player, so that these customers will get it when they buy the player. They have to build an app for Netflix, for iPhone, for Xbox, for Android, for every other scenario. That's also a cost, and you just have to do it. Otherwise, the end customer who wants to watch the movie X cannot, because the TV is dumb and the device that they connect to it, say Xbox, for example, needs to have the Netflix app. And that needs to be provided by the Netflix company, even today, like you see in the example here. This is provided by the Netflix company. Same with every other platform. So that's the cost. Either you make your own box or you don't. But if you don't, then you have to inject your software into multiple boxes already out there in customers' places. Inject means install the app. So like iPhone installs the app from the App Store. This app from the App Store on the iPhone. That application injection has to happen so that this device, which currently doesn't, can install the app like that, pretty much like that. It's going to install the app pretty soon. Now the question is, should you, having understood that there is a cost to doing either way, whether you build your device or you don't, now that you have understood these aspects of the two scenarios, would you still decide to build a device or not?
I think the app would be the better way to go.
App is a better way to go. Why would you think that?
I mean, it seems cheaper cost-wise.
Cheaper?
And like you said earlier, you don't have to make the customer buy a new device.
Yep, exactly. I think you're thinking in the right direction. There is another way to think about this, as rather one more aspect to think that is not super obvious, which is you have this dumb television. It is dumb. It has, inputs, typically 3 or 4. They are called HDMI inputs. They're typically limited to 3 or 4. And in most homes, you have something connected. Like maybe a set-top box, Xbox, or God knows what. Some doodad is connected to the TV, and all of it is basically hiding behind the big screen. It's like in there in the living room on the back side of the TV where nobody wants to ever go. The people are lazy, right? Just like the TVs are dumb, people are lazy. And so nobody wants to go to the back of the TV to hook up a cable, ask somebody, hey, can you change the HDMI input? And people will grumble, say, no, I will not. And that's common behavior. That's human behavior. So now you're asking for a difficult thing. First of all, these ports are occupied, and now you want to add one more device. No, I don't want to go in the back of my TV. That's it's called lethargy or laziness. And so basically, people are so too lazy to get up and connect one more cable. Even if they manage somehow to do it, they spend money, buy a box, put that cable somehow. They still have this inertia. Inertia is to switch the HDMI input. That is also, there is inertia in there. Like, people don't. And that is a friction point. When you make people do things that they don't want to do, they will not do it. So when they don't change the input, you will not see the Netflix app or the Netflix device, and then you're screwed. Now people are not using it. So when people are not using, they're not paying for your subscription, and then you're royally screwed again. And so you don't want to be in any of these inputs. But right there, which is the default, because you know that people are lazy, lethargic, they don't want friction, they don't want their heavy inertia. People ask people to do things and they will not do it. That's the default human behavior. And you have to understand these details when you're in the business. And that is one of the things that they discussed and considered that, having your own device is not going to actually create anybody any good, especially not create any good to the Netflix company, because people are lazy. They will not change input even if you give the device to them for free. And then people will not actually watch Netflix, and then they will cancel subscription, and then Netflix will lose money, and then we are screwed. That's the reason why they don't have a device. It doesn't make actual too much sense to create one more variable in the customer's hand to handle for them to do. The best way to deal with this scenario of handling this idea of customers being lazy, which is a good thing. I am lazy too. In fact, I'm one of the laziest persons you can think of. But I go to great depth to allows me to become lazy. So I will go like hardcore that will eventually afford me laziness. So we know that people are lazy, and we want to keep them that way, honestly, because you want to actually be right there where they are. So if they are holding an iPhone in their hand, you want to create an app that fits right in the phone. Don't even make them change your device, because people are lazy. So you want to create an app for the iPhone. There's people who carry Android, so you want to create an app for Android. People who use PCs, so you make an app for PC, or rather make it use with the browser, so that they don't even have to install a separate app. It just runs an HTML5 app in the browser. That's the dominant usage. Most people watch Netflix on PCs and Macs. You don't even have to install anything. Just open the browser, go to netflix.com, log in, and play. It's an app that runs HTML5 video. And that's what you see. Most people who use PCs or Macs use it that way. Same story with other devices. People who have the dominant device, that they need to understand what people are using at a given time or in their home, which are most popular devices. And you focus just on the popular devices, not all of them. Like these guys seem to show you right now, like a large collection of devices. It's a huge list now these days. It's a really long list. When it started, it was not that long. It was really short. It was like a handful, like 3 or 4 maybe. And they just focused only on the popular devices and excluded everything else. The key idea to think about when you start something new is this. Less is more. That's the way to think. So do less. Do the lowest amount of work you can get away with, still making majority of people happy. And so this is actually a translation to you being lazy now, where you're doing less because less is more. So you're not spending your energy and effort in 100 devices, but only doing those 4 popular devices that are really, really popular. And you apply the Pareto principle in making that decision. So Pareto principle is, you may have heard of before. It is also known as 80-20 rule. You may have heard of this rule. Let's go read that rule if you haven't. If you have, just tell me, I'll skip. Pareto principle. So that principle is also known as 80-20 rule or the law of vital few. See that? That's a good way to say it. Law of vital few, or the principal factor of sparsity. So this is very, I like Wikipedia very much. What it really tells you is that roughly 80% of the effort comes from 20% of causes. So you do 20% work to accomplish 80% impact. That's the underlying concept. It is coined by an Italian economist by the name Vilfredo Pareto. That's the name of the person. And this is Pareto principle, which is, I think these names, the law of vital few or the principal factor of sparsity, is a better way to describe Pareto principle. So that's what you're looking at, is not so many devices to begin with, but only a few, handful, 20% devices out there you cover, that'll get you 80% impact. And that's less is more applied to this discussion. Having said, we have broadly, what we did just now is discuss this problem of serving this customer with the idea that he wants to or she wants to watch X movie on that device that they carry. And so you, as a company called Netflix, needs to service this movie X to that customer screen and on demand. On demand. So to accomplish that scenario, we need to have a 2-part solution to it. One is this side, one is that side. This side is the cloud end, and the other side is a device end. In other words, it is called the client end, and this is called the server end. So you need to write something here on the application to serve this X, and you need to write another application here called the client application to show this X. So here you want to serve, here you want to render or show. So the 2 parts to the puzzle. And you want to remember this, less is more as we go along. So we will now have to think about, there are 2 key development efforts that need to happen for such a solution to be implemented. A large majority of our discussion will be focusing on the cloud side, the cloud end, because this is Cloud Bootcamp. We will not focus too much on this side, but yes, we will pay attention to what is needed on the render side of the application that gets installed, like this just got installed. So you can open and it will show you the app. Now this is not the cloud piece of puzzle. This piece that you're looking at is the device end of the puzzle, the client application, which is also created by the same company. It is running on my device here, which is right in front of me, and I have this desire to watch X. So this server needs to serve from the cloud side, or rather stream from the from the cloud side that movie on my device in the app right here. And of course, I need to sign in, and I will do that pretty much like this. And now I can sign in, and there we go. So I'm not going to play any movie, but I'm just showing you the experience that you already know. So the client side application developed here is what you're looking at, is the piece that you need to write in for every device that you want to focus on. So let's go stick to something like iOS. There was no Android to begin with. So web browsers, that was a big, and then Xbox, PlayStation, Nintendo. Those were the big ones, I think. So Android was not there to begin with. Web browser for PCs. You create 1, 2, 3, 4, and 5 applications to begin with. These 5 applications will operate kind of sort of similar to what you're looking at here. No, not here, here in this. That's what you're looking at essentially. But they will be written in Objective-C. They will be written in HTML5. Or Xbox code is written in, I think, .NET. I don't know how PS2, PS4 code is written, so I have no idea. But I think I remember they created an HTML5 app for for PlayStation. I don't exactly know how they did it. Nintendo is similar. I don't exactly know how they implemented, but these are different pieces of code you have to write in a variety of languages and structures of creating applications for a variety of platforms. And that is your collection of device solution for the client or the user to imagine whatever they want and ask for it to be delivered. So that's the device end of the story. We'll focus most of our attention on the other end of the story. Of course, we have to come back to this idea and understand what does it take to actually build and what are the dependencies it requires on this side, so that we can complete the idea of a new request for a movie called Y, originating from the customer's mind, and the request going in that direction and the rendering coming back. That end-to-end pipe has to be really, really understood. We'll do that. Next, the next idea that I want to talk about is that in order to enable this kind of a setup, we need to really understand what does it take for a video to show to a device in streaming as opposed to playing. So for example, if you look at this, and here is a video, and I'm going to play it now because I just accidentally recorded it. It's a video. I'm playing it right now. So here I go, play. And this video is whatever it's showing you right now. So some blinking red dot. That's the video. And something changed. So this playing is happening on my device, as you see. But is that streaming? Was it streaming right now? I played a video. Was it streaming? Let me show it to you where I got it from. I got it from my Photos application. And so that's a video I have. Apparently, I don't have much videos here. Maybe there are 6 videos, it seems. So yeah, the player video, it plays, and that's it. Now the question is it streaming or not? That's the question I really wanted to ask. I play the video, you see it, it plays. It's a dumb video. Question is it streaming or not? Or in other words, I'll ask this question differently. What is streaming?
So I would say it's not streaming, being that it's saved to your, I mean, it's saved locally to your
Correct.
computer.
Yes, you're right. It is locally stored video in the Photos app. Locally stored. And it is simply a playback of a local file. So playback of a local file is different from streaming. Let's see what streaming does. So let's go to something like where it's very well known for streaming, and I will go to a place where I will like to, well, it is not well known, but I'll go there. And here it is. And I'm going to play a video because I can always go to YouTube and play the video there, but I don't want to because I don't want to run into copyright issues. So I'll play a video on which I own the copyright. Like for example, you've seen it here. These videos are actually coming from a streaming service. I'm going to play them now. And here it is, play. So I play. And these videos, you can actually scroll ahead like that. And it plays. Like I can go full screen, all that good stuff. And I can, minimize and all the things that you're seeing. The video is playing right now. I can pause it. But what's the difference in this kind of a play that I'm looking at right now? I can rewind and go forward, backward. Versus the video that I played here, this one. I can here also I can go forward and backward like this. So for example, here I'm going forward and backward. See that? So I'm also going forward, backward, but there is fundamental difference in the two scenarios. One is a local playback, the other is streaming. So the question that I'm really asking you is, do you understand what streaming actually is? That's the real question. And you really understand it because the whole game is about streaming, the whole Netflix game. We will be discussing streaming quite a bit. That's what we are going to understand. How does Netflix stream? For which we need to know what streaming is. So that's the direction I'm really headed towards, is to help us clarify our understanding of difference between a playback of a locally stored file compared to a file streamed to you. Like this is a streaming example. So I stop the playback, I go to another video and I play that video and I am streaming again. And you see the timer going off. You see my mouse moving and things like that. So you can even scroll a little bit if you like. And so that's what you look at. But the question I still have is, what is the real difference between streaming and local playback? Okay, so I'll explain. It is like this. I'll explain it in a simple fashion for us to understand it very, very clearly. So in a local playback versus streaming, if you have a file that stores in your hard disk or solid state disk, that file is called a.mp4. That's a video file. The whole file is available right here locally. And when you play it, you just render each of these frames inside the picture in the movie, one frame at a time. So what a frame is basically So let's go see if I can find the idea of a frame. You may have seen old videos, like really old, like 200-year-old videos. You may have seen them on YouTube, where you will find that it kind of plays in a erratic fashion. Let me see if I can pull up that thing here. Maybe here. So the thing is called, there's a name for it. Uh, old videos. Stuttering, no. What's the word for a video that you may have seen, like Charlie Chaplin, right? Charlie Chaplin videos. You may have seen those. So I think I'll describe it here. It's easier. So you may have seen the Charlie Chaplin old videos. Will have a person, which is Charlie himself, walk around, and he walks in a crazy fashion in which, the hand movements is like almost sometimes visibly distorted, in that it you can tell that it is motion of a person moving his hand like this, and then again now the hand is going to go that direction, and then when the hand moves, you can actually tell how the hand is moving around. Have you noticed such a thing? Old, slowly moving. They're called slow movie for a reason, because they move very slow. Have you noticed such a thing? What I'm talking about? What do you call such a thing? When you have a picture after a picture after a picture rendered, but not fast enough that you can detect that it is not actually a movie, but it's a sequence of pictures shown one after the other. What do you call that thing?
I know what you're talking about, but I don't know what it's called.
Okay, good. But I think
Yeah,
I accomplished my
I
goal.
don't.
If you know what I'm talking about, that's good enough. So what I'm really talking about is that thing that we don't have a name for. But imagine this: if you have to have a picture followed by another picture followed by another picture with slightly different. So I have to imagine this is my person, and my person's hand is here, and the hand is now here, and the hand is now here. Like the hand is slowly going downwards. If I'm showing these pictures to you, now the hand is going to go back up. And so see how the motion of the hand is going as you repeatedly show this picture, then this, then this, then this, like that, in a screen sequence. That's how movie is created, by the way. That's how a motion picture is constructed, by putting together sequence of pictures one after the other, and these things are called frames, because they show frame by frame, picture by picture, taken every so often in a rapid sequence. If you are able to conduct a rendition of 24 frames or more in 1 second, that's a condition. If you're showing 24 such pictures in 1 second, and you keep showing, like that's what the old style reel used to be, right? If you know, movie reels used to be like this, and you just run the roll on a rapid speed, it'll just show the picture after picture after picture, 24 or more frames per second. That's called FPS, by the way. In modern TV language, you will see TV with 60 FPS, 120 FPS. Those are ratings you will see in Costco if you go buy a television, frame per second. And so the higher the frame rate is, the smoother the motion appears to be. And this is the cutoff point, by the way. If you cut off below this number, so if you say show 15 frame per second, you can tell it's a Charlie Chaplin type movie, because you can detect breaks in the motion and it is not smooth. So that's the idea of a frame rate. And human eye can detect motion is smooth if it is more than 24 frames per second. If it is below that, humans can tell it is not a movie. You're just showing me picture after picture after picture. Are you kidding me? That's the difference. That's the threshold cutoff for human eye. And of course, higher is better. It looks smoother. But besides, let's say more than 30 or 40 frames per second, you cannot really tell unless you're actively interacting with the thing in the video, in which you're playing a game, in which FPS is important. But if you're just watching, 30 frames per second is good enough. You cannot really tell unless you're interacting with the scenes, or if the scenes are really high motion activity, like shooting and high speed car chase or planes flying, then you can probably detect. But 60 is a good enough number for frame per second. So what this translates to in a local playback is that you have to actually understand that every video like this, for example, this video, if you inspect its properties, let's see if I can find properties of the movie. This is not a PC, so not a Mac. So I'll cancel it. I cannot actually inspect properties in here very quickly. No, not possible on the iPad. But I'll show you next time. Maybe right click on a movie as you already have, and you will see some of the properties of the movie itself, which will tell you the frame rate. It'll also tell you the resolution. And we are talking about local files. The resolution is basically the width and height ratio. Older days, it used to be 4:3 ratio. Newer movies are typically, actually not say movies, newer videos are typically 16:9 ratio, sometimes 16:10 ratio. And if you go to theaters, the movies ratios are probably more like this. And so it is more like 16:7 sometimes. It's a widescreen ratio, even smaller sometimes, really widescreen. That's a classic movie theater experience, widescreen movies. You have other scenarios of resolution of various types. For example, let's go see the idea of resolution here. So we'll now open up a browser window. Where is the browser? Here. And search for screen resolution. And you will find this picture. And this picture is actually telling you something very interesting that you may already know of, but I'm going to expand it and see if I can. Yeah, here. Let's go see this portion up to the point where the item is at 640 by 480, this number, 640, 480. It's called VGA. If you match that ratio, 640 by 480, and put that in the corner, the upper left corner is 00, and you go all the way where VGA arrow points to at 640 by 480. If you look at that rectangle, it is your 640 by 480 ratio, which is the old style VGA monitors in old computers. If you look at US television, older TVs, they used to be, where is US television? NTSC. I'm looking for NTSC. I see Indian television, but I don't see US television here. Do you see a reference to NTSC here somewhere? I don't see it. Oh, there it is, below VGA. Right below VGA, I see NTSC. Right there, in the same column as VGA itself, 640 by 480 NTSC. And Indian televisions are slightly different number in PAL and PAL asterisk and PAL exclamation. There are two different signals or resolution factors, resolution ratios for different countries. They used to be slightly different. But if you now look at our classic HD television, so you have to scroll this a little bit and now go to the point where you will see, eventually find out HD TV is at 1920 by 1080. It is at that level. So you see that segment right in the center, HD 1080, that item. If you look at that one, I'm going to minimize it a little bit, and you will see the pointer to that arrow where it is mapping and compare it with what used to be the VGA or the PAL or the other resolutions in the game here. See how big the HD 1080 is. That's your HDTV scenario. HDTV resolutions are 1920 by 1080. Now, if you look at the computer that I have, like the one I use, the one I have drawn, that's a 4K monitor. And so 4K monitor is at the very bottom here in this picture, is 40962160. That's the entirety of the screen in this image. So on the very top left to the bottom right, the entire gamut in this image is captured by these numbers 40962160, and that's the relative size of resolutions that you're looking at in this picture. You can always go back to that pictures on Wikipedia so you can find it. So what we are looking at is that these resolutions that people have in a variety of devices that they carry with them can range from anywhere between, say, a old style television 480 640 to a newer television 1920 1080 to an even newer television, say, whatever that number was, 4096 here, 4096 by 2160. That's the resolution. So we have these are old TV, these are HD TV, and these are 4K TV. Now the other machine I have here on the other side is a 5K machine, 5K Retina iMac. And that's even outside the scope of this resolution. So what we are now looking at is that variety of people with carry variety of devices, each with its own unique resolution. And people expect to find that their video that they're looking to play, like the X movie or the Y movie, whatever they have, they expect that the movie plays in their full screen capability. That's the expectation people have. People also expect that the movie shows smooth, at least 24 frames per second. That's the expectation. So when you're playing a local video, let's understand how much capacity is needed to store a video locally in its raw format. I'll talk about a little bit of formats. And so we are all talking about local videos, not streaming yet. We have talked about resolution, also known as screen size. We talked about frame per second. And what we want to now calculate is the file size needed for a 1-minute video. Let's try to calculate in a very empirically. So imagine old TV, 640 by 480. And I want to get 24 frames per second. And I want to get a 1-minute long video. And I want to store it in RAW. Now, every picture in these pictures or frames per second, these are per second, right? So there are 24 frames in every second. And I want to go 1 minute long, at least. I want to calculate the size of the file. How will I do that? I will say I have 60 seconds. And I need to get 24 frames per second. So I need to have that many frames. And then for each frame, I need to have a resolution of 640 by 480. I mean, that many pixels now I have, these many pixels. And each pixel can hold a value of red or green or blue. So it's a color picture. That means I need to multiply by 3. And then each picture can store a value of up to a byte. Each pixel in red, green, and blue will store a byte value. That's how a picture is constructed, by the way. So we are now talking about 60 by 24 by 640 by 480 by 3 bytes for just 1 minute of video. So let's calculate this. And so I will open spreadsheet and do the math. Where is my spreadsheet? I hope you understand my math. And so let us, if you have a question on the math, please ask me. Okay, apparently I'm not signed in, but that should not hurt because it should let me type. Oh, no, that's up. Not letting me type, so no matter, doesn't matter. I'll open up another spreadsheet right here. Or just calculator. Why I need spreadsheet? So just calculate. So we have 1 minute, 60 seconds. We have 24 frames. Sorry, I need to put a multiplication sign there. So 24 frames. Then I have 640 by 480 pixel. Then I have 3 colors. And then I have, is that the math? Yeah, that's the math. Let's check. Here is the number. We got 60 by, let me compare, 60, 24, 644, 83. So that's the math. This is the number. That many bytes in 1 minute of video in raw format, right? So let's convert that byte into megabyte. So we divide by 1024. And that is the number of megabytes. Now we divide that by 1024 again to get the number in gigabytes. See how many items we are storing in just a tiny little old style video for 1 minute. You see the size there. You see the calculation there. 60 seconds, 24 frames per second. I missed a zero there. Hold on. Hold on. Missed the zero. There. See, the size is amazingly big, huge, because it is raw. We are storing every single pixel in 640 by 480. We have, basically 640 by 480 means that there are 480 lines and then 640 columns. And for every item, we have a pixel. That pixel is in 3 colors, R, G, and B, red, green, blue, and each of them stores a byte value. That's how a picture is created. And we have 24 such pictures every second. And in 1 minute, we have 60 seconds. So imagine the amount of file size we have to really deal with when we are dealing with just an old style television. Now you grow it like this in the other direction and go to newer screens, you are creating a nightmare for yourself, aren't you? Just by the size of the file itself. So how do you solve this problem? We have a gigantic file size. For just 1 minute long video, we're not talking about 3 hour long videos. The movies are typically 2 to 3 hour long. X and Y, and Indian movies are even longer. And so this is a minute video and you're already into gigabytes. Are you kidding me? But no, I'm not. That's how reality is. I just showed you the math. And I just showed you the math for the oldest screen of 640 by 480. Like nobody has these days anymore, that old TV. For that TV to carry a 1 minute long video in its full raw format, it will be like a couple hundred gigabytes or more. Now imagine transmitting that many gigabytes on the internet to you when you want to see this movie X from the cloud, Netflix cloud, and you want to watch it, let's say on the old television, and you expect only this resolution, you're still talking about hundreds of gigabytes flowing every minute. Huh? How is that even possible? Not possible. Even in today's bandwidth, not possible. I cannot really sustain this kind of a download every minute. Nobody would be interested in such a, because it just crash the whole internet if you go like that. It doesn't work out. So we have to have a solution for this problem. What is that solution called? Do you know what that thing is called? There is a solution to this problem. It is not that big of a video. In fact, if you look at like a minute long video, it will be about 2 MB, roughly, actually speaking. And so I just calculated this number to be about hundreds of gigabytes for every minute. And I just told you that in practice, the file size is typically like 2 to 3 MB for a minute of video. So what is going on here? 2 to 3 MB, hundreds of GB. Who's kidding? Like, who's right? What is going on? Do you know what this thing is called? This is called compression. Also called coding and coding. Coding, decoding, also known as codecs. So that's the underlying concept that enables compression of a large raw video into a file that is usably small, but still plays like full that you expect, like this 24 frames per second, and shows you all the colorful pictures and frames and everything, just like this video plays, or any other video that you play locally. Are you with me? Do you understand what I'm talking about right now? Do you? Does it make sense to you?
Yes.
Okay. Now let us look at some codecs. And by the way, in this picture that I talked about, just took care of the video portion, and I did not even include the audio portion at all. Audio did not even do the math. There is similar math for audio also, and I'll show you the math if you need to. But we just calculated only the raw number for video. We ignored this completely, which is not true. So these codecs help you do in coding, decoding, compression on video and audio. And every company or every major manufacturer of devices will have their own codecs. Like, for example, you may have heard of this thing called if you haven't heard of it, please say. I will write down various names. If you don't know any of these, just call it out.
I'm sorry, what was the question?
If you don't know these codecs, these are names of codecs that I'm writing on audio and video side. If you don't recognize any of these guys, please tell me, and I'll point out what these things are. But I'm assuming that you already know what these things are. So some of these are open source. This is from the Apple company. These are from Microsoft. And these are from a consortium called MPEG-LA. MPEG LA. It's a consortium of companies that include Microsoft and Apple and a bunch of others. I don't exactly know who are in this group. It's a group of companies that control these formats or codecs. MP4, MP3, they're very popular. You probably already know these things. Windows mobile, Windows Media Video, Windows Media Audio, M4V and M4A are Apple codecs, and MKV, Theora, OGG, FLAC, free lossless audio codec. So some of the open codecs available in the open source domain as well. There are more codecs like VPC codec from Google, and Cisco has a codec also. So I don't exactly know what they call it these days because they have open sourced that codec also. So Cisco did open source some of their codecs that are used in this game, in this game of encoding, decoding. But bottom line is these codecs help reduce the size of the raw file, whether it is audio or video. And by enabling that idea of compressing them down, you make the file usably small and playable locally. So that's the idea of local playback. So the files are small and you can play and you see a good video output. But even to transmit a file like that, for a 3-hour long video, it'll be like a decent 2 or 3 GB, sometimes more size of the file itself as you store it locally. And so encoded file stored locally for a video could be about anywhere between 3 to 5 gigabytes. Imagine transmitting a 5 gigabyte file from the cloud to you when you press play. You want to play the X movie and you press the play button, you wait for the 5 gig download to happen. Because only after the download happens that the file becomes locally available, and then it plays. Until that time, it is buffering, meaning it is downloading the whole file. That's also a bad experience. People don't want to wait. People are not only lazy, they're also impatient. And I'm talking about me, not about anybody else. I'm talking about me, who I think is one of the laziest persons and also highly impatient. So lazy and impatient. You ask a lazy person to wait for what? 5 GB download? Are you kidding me? I'm watching something else, not this. That's how they will behave. So that's where this idea of streaming comes along. Streaming, where you don't download at all the whole file. It does not get downloaded here at all. So what's going on? What's going on essentially is, if you have a file that's like a 3-hour long video, let's call it X video. It begins at here and ends at 3 hours. You take that file and you split into chunks. Split the file in like a small chunks of say kilobytes, as opposed to this gigabyte entire file. Use 100 kilobyte chunks. That will correspond to like a few second, 1 or 2 second of playback. Really small chunks of the whole video into small bits and pieces. But you organize them, you label them properly. So this is your chunk number 1, this is chunk number 2, like number 3, and this is chunk number, I don't know what, 3, 6, some number, random number. I don't know, some number, chunk number n, let's call it n. So that many chunks, 1 through n. And you got these chunks. And what you're doing essentially is sending chunks. and sending chunks and playing the chunks here and not having to wait for 5 gigabit download to finish on the other end, but instead you get this chunk called chunk number 1. You get like a 2-second video. You have this 100 kilobyte chunk sent. On the user side, it'll play 2 seconds and be happy about the idea that you just played successfully 2-second video and you're done. You just play through 2 seconds, 1 second, and 2 seconds, so that it finishes there. And then that video playback finished. But in the meanwhile, you send the second chunk and then you play the second chunk. It's kind of trivially simple after that. Once you break the whole thing into smaller chunks, that you're sending chunk after chunk after chunk like that. And it just goes, not individually in one big package, but instead small chunks. These chunks reach the other end and it will be rearranged in the fashion that you expect in the sequence 1, 2, 3, 4, all the way through n chunks. And they will be played back in the sequence that are they marked for in that sequence. And thereby you are accomplishing playing the whole movie. Let's now see this example. I'm going to play this movie, but not at 13, whatever that number was. Let's go play another movie. So refresh. Not playing. Come on, play something. Oh, there it is. Started playing, right? So something is playing there. But why is it not letting me? Okay, I'm going to kill the browser. The browser dies. Come on, die. Hello, browser. What is going on here? Hold on. Close. Yeah. Browser and play. So now you can see that I am able to see the timestamp moving forward, right? And I suddenly pause the video. And now I want to switch from this time all the way to forward. Go forward all the way like this to 1 minute 54 seconds in sorry, no, it's not 1 minute. It's 1 hour 54 seconds, 1 hour 54 minutes and 8 seconds. So stop there. And now I am going to play. Does it mean that the whole video up to this point needs to be available locally on my iPad? No. All it means is that the chunk number, whatever it corresponds to, that chunk number is the one that I expect to receive next. And so when I play this play button at that point in time, oh, sorry, hold on. At that point in time, and then at 2:21:23 I play, I will receive the corresponding chunk, and that chunk will play as soon as I hit the play button. And it is now playing from that point onwards. And you can see it visually very, very clearly, because as you can understand, we are asking for the correct chunk in that time frame, 2:21, whatever that number was, 22, some number. In that timestamp in the 3-hour long video, I'm asking for that chunk, which may correspond to some number here. And I'm asking for that chunk to be sent over to me, which is only 100 kilobytes. And so that chunk immediately gets delivered to me and I play and I'm happy. And that's the idea behind creating chunks and small chunks and arranging them in a proper sequence that you expect, that the user expects, and sending them on demand whenever they need to. And so there are several benefits to this way of operation. And I think we have timed out, but no worries. I'll just finish this idea before we break and then we move on to the next session after that. But the couple of benefits in this chunking business, which is what the underlying idea of streaming is that you, first of all, don't send the whole package. The second idea is that you accomplish quick delivery, because you're sending only so many kilobytes, like a few hundreds of KB at a time. You just send the chunks, the small chunks. The third thing is that the user here who wants to get this movie X cannot really get the whole movie X. They cannot pirate, because all they got is chunks. And you are creating these chunks at the source, and at the destination machine here, you control the experience. So your app that you run here will make sure that you destroy the chunks that are watched already, that you delete them. And by deleting these chunks, it is very, very difficult to pirate. So streaming helps you not only quickly deliver the content expected, but also prevents piracy to some extent. It's not exactly possible to completely eliminate piracy at all, ever. And I just said ever, because of a problem. And that problem is impossible to solve. And it is called the problem of last mile. Or rather, no, the name for it, the problem is called, I'm forgetting the name. So, yeah, it's called analog hole. Analog hole. So this analog hole is inevitable. This is why piracy will never go away. It is inevitable. And you can read more about what this idea is if you are interested. But understand that piracy is not going to be completely eliminated ever, because it is impossible. It is fundamental and inevitable. So read more about it if you're interested. But it reduces the chance of piracy by chunking it and deleting the chunks that are watched already, so that the user doesn't have the whole video. So they're less likely to pirate. It delivers quickly, and it rearranges the expected video and on the user side according to what they may want. So for example, I start watching video at t = 0, and then I switch forward into 2:21, 22, and the movie is actually 3 hours long, which is fine. I just get to that point in time where I am interested, and I just play watching from that point onwards, and that is fine and smooth, because all I'm receiving is the chunks that I expect next, and I'm ignoring all these chunks. I don't care about them, because all I want is this point in time forward. So I just get those chunks, and I'm happy, and Netflix is happy, and everybody is happy actually, because the bandwidth was not wasted in sending you these items, because they were not even expected by the user. The user expected to play from this point onwards, and so they receive only those chunks. So that's the underlying concept of chunk creation, which is the idea behind streaming. And now we will stop recording and get together again on the next time. So let me see, this thing is new to me. I'm going to just find a way to stop this recording. How do I stop it? Let me go back to Zoom. I think Zoom is where it is. So where is Zoom? Where is Zoom? Let me just close this guy, this guy, this guy. That is Zoom, right?
Nilesh, I got to drop. I'll talk to you on Wednesday.
Yep, absolutely. So I'm stopping to record, and I'm open for questions.
Thanks.